Okay, good afternoon and welcome back, everyone. So, our next element and the last element of IG2 and the entire Nebosh syllabus is element number 11, electricity. Okay, so basically, in this element, we're going to describe the hazards and risks associated with the use of electricity in the workplace. And we're also going to describe the control measures that should be taken when working with electrical systems or using electrical equipment in all workplace conditions. Okay, so what are the hazards of electricity? So starting off, we'll give a small introduction about electricity. Electricity basically, in simple terms, you can define electricity as the flow of electrons. So when the electrons of a conductor move from one part of the circuit to another part, it is called, that's electricity. So the flow of electrons is called electricity. An electrical circuit, basically, it has three parameters. It has voltage, it has current, and it has resistance. What do we mean by voltage? Voltage, basically, it is the driving force which moves the electrons. Okay, so voltage is also known as the potential difference or the potential, and it is measured in volts. Current is basically, that is the rate of flow of electrons. So how many electrons are passing through a conductor per unit time, that is called current, and that is measured in amperes. So the rate of flow of electrons or the rate of flow of electricity is called current, and it is measured in amperes. Then there is resistance. Resistance is basically the opposition to flow, resistance to the flow of electrons. Um, that is measured in ohms, and there is a simple formula given by Ohm's law, which is given as voltage V is equal to I into R. So you can calculate the voltage by multiplying the current I by the resistance. So this is called the Ohm's law. Okay, moving on to the next slide. You won't need this information for your what you call it assignment. So this is not important. Don't need to remember all of this. So V is equal to IR. That's the formula. Basically, there are two types of current. There is alternating current and the direct current. Alternating current is usually from the main supply, which we get. That is alternating current. Voltage alternates from positive to negative back and again, and the current flows backwards and forwards. In UK 220, US 120 volt is used. Direct current DC, this is the supply that we get from the battery, and the current flows in one direction only. Okay, this is important to remember. What are the hazards and risks of electricity? Obviously, electrical shock. Okay, that is one of the most common hazards of electricity. Burns, your skin will get burned. Fires and explosion will be there. Arcing is a major hazard, and there are secondary effects of electricity as well. Electrical shock, usually, obviously, there is a threshold of what you call it electrical shock. If the current flowing through your body is between 0.5 to 2 ampere, that is the threshold of sensation. You will start feeling it. You'll feel that current is flowing. 2 to 10 amperes, milliampere, sorry, there will be tingling sensation, muscle tremors will be there, and slightly painful sensation will be there. 10 to 60 milliamperes, that will cause muscle contractions. It will it will have the inability to let go. So if you have grabbed an electrical wire, or if you're in contact with an electrical conductor, you won't be able to let it go, and inability to breathe. 60 and above, you will get ventricular fibrillation. It means your heart will stop working, cardiac arrest, extreme muscle contractions will take place. You will get serious burns to the skin and at the point of contact and inside the deep tissue as well. So it depends, the severity of the electrical shock depends on how much current is flowing through your body. Okay, so in addition to the current flowing through your body, there are several other factors which influence the electrical shock. So the electrical shock, it is influenced by voltage. Higher the voltage, greater the current. So hence the greater damage you will get from the electrical shock. The duration of the shock, how long your exposure was to the electrical shock, that will also determine how much damage you get from the electrical shock. Guys, please keep yourselves muted. Okay, current path, the route the current takes through your body, that will also determine how severe the shock is. Resistance of your body, your clothing, etc., that will also be a defining factor. Contact surface area, how much part of your body is in contact with the conductor. Environmental factors such as metal surfaces, humidity, etc. Clothing and footwear, obviously, if you are wearing resistant shoes, etc., it will reduce the current flow. Frequency, AC alternating current is more harmful than DC at the same shock current. Okay, electrical burns, basically they are direct electrical burns, and then there are indirect electrical burns. Direct electrical burns, obviously they are caused by current flowing through your body, and the burns will happen on the entry and the exit points, and there will be internal tissue burns. Indirect electrical burns, basically they will happen when an electrical accident causing something to overheat or explode, for example, an arc or a flash. So you are not directly in contact with the electrical equipment, but you are standing at a distance, and you are feeling the heat of that arc or flash or overheating, and you can get burned. That's an indirect burn. Okay, this is very, very important. You can use all of these causes as hazards if you're doing a risk assessment. Okay, so all of these causes over here, these can be used in the hazards column in your risk assessment. Okay, so what are these? Number one, faulty electrical equipment overheating, overloaded electrical systems, overheating during charging, that can also generate a fire. Equipment may be misused, flammable atmosphere, um, with the wrong type of equipment, and it can be accidentally created as well. Electrical equipment producing heat or sparks in normal use, poor internal electrical connection. So all these are hazards. Static electricity basically is the buildup of potential difference between surfaces. It is caused by friction. Surfaces, they become charged when you rub them. For example, in the winter, if you're wearing silk or if you're wearing other similar clothes, if you rub it, you will hear tick, tick, tick sound. That is basically static electricity. Static electricity sometimes can give a small static shock as well. Very short duration static sparks are generated. Sparks caused on contact with earth, and there is a risk of igniting flammable liquid. So static electricity still has a lot of energy, and static sparks can cause a fire as well. Arcing basically is the ability of electricity to jump across a gap, an air gap. So basically, if you have what you call it, a circuit, and there is a gap between that circuit, and you one what you call it, there is a small opening. If the voltage is sufficient, the electrons will start jumping from one part of that circuit to the other part, and the air in between, it will start to fuse, it will start to burn as well, and that will cause arcing. Arcing is a very, very severe what you call it, kind of spark. Okay, main hazards of arcing include electrical shock, direct burns from the arc, indirect burns from the radiated heat, damage to your eyes from the ultraviolet radiation. Secondary effects can also be caused by fires, sorry, electricity. If you get an electrical shock, you might fall off a ladder, or if you might be working at height and you might get an electrical shock and then fall off, which will cause cuts, bruises, and broken bones. Dangerous activities, basically, these are also hazards which you can use in your risk assessment. Okay, when you use poorly maintained electrical equipment, that is a very, very hazardous activity. Use of electrical equipment in wet environments, working near overhead power lines is very, very dangerous. Contact with underground power cables and working on the electricity supplies, mains of the electricity suppliers. These are all hazardous activities and dangerous activities. Okay, then there is fixed and portable electrical equipment as well. So the conditions and practices which are likely to lead to accidents related to fixed and portable electrical equipment include unsuitable equipment, using equipment in damp conditions if there is water around, misuse of electrical equipment, physical abuse, improper repairs, for example, taping of the joints, use of faulty defective equipment, chemical abrasion, lack of inspection, testing, or maintenance. So all these are hazards related to electricity. Now, what are the control measures? Number one, protection of the conductors. Very, very important. You must protect the conductors always. So the cables, the electrical cables, they must be protected. Other conductors which are carrying current, they must be protected as well. So insulate protective conductors must be protected by insulation to prevent contact with the live conductor. Cable coverings should be unbroken, equipment casing should be intact, and you should inspect to ensure the protection is in place and ensure electrical panels are locked. Okay, so electrical equipment that you use, you need to make sure you use suitable strength and capability of equipment. Electrical equipment must be carefully selected to ensure that it is suitable for the electrical system and the tasks that you will be performing. So you need to use suitable equipment, and it should be also suitable for the environment which you are using it in. While selecting the strength and capability of equipment, you need to consider the weather, the natural hazards such as gnawing by the rats, because the rats will damage it, extremes of temperature and pressure, dirty conditions, corrosive conditions, because all of these things, they can damage the insulation of the conductor. Liquids and vapors, splashing, flammable substances, and foreseeable mechanical damage as well, such as wear and tear. Then protective systems and devices as well. You need to make sure that you have adequate protective systems and devices installed in your electrical equipment, such as fuses and miniature circuit breakers. Earthing should be provided, isolation of supply, double insulation, RCDs, residual current devices, and reduced or low voltage systems as well. Fuses and miniature circuit breakers, basically they are very, very helpful. Fuses, they prevent the current overload, and basically it's an overcurrent protection device. So whenever there is overcurrent or excess of current, the fuse will break the circuit. It is basically a weak link in the circuit. It overheats and melts if the current exceeds the fuse rating, and it is designed to protect equipment and not the people. It has certain advantages and disadvantages as well. Miniature circuit breakers, they are similar to a fuse. They prevent current overload. It's an overcurrent protection device as well. It's an electromechanical device. It trips a certain switch. It can be reset. It is tamper-proof and designed to protect equipment and not the people. Earthing, basically, in the event of a fault, provides a safe path to the earth outer metal casing connected to the earth by a wire. So if the inner conductor or inner, what you call it, wire comes in contact with the metal casing, it will make sure that the person who is touching the casing, he does not get electrocuted, okay? Because it will provide a very, very path of least resistance to the earth through the earthing cable. Hence, the person, if he comes in contact with it, he will not be electrocuted. And electrical shocks, if there is any, it should be minor. Isolation of supply is very, very important. Basically, you should never ever work on live electrical system unless it is necessary. If you have to work on an electrical system, make sure you switch it off and isolate the supply, so that if you're working on it, nobody should be allowed to accidentally switch it on. So the removal of electrical power from a circuit or a system is called isolation of the supply. You switch or isolator is turned on or off, or you remove the plug. The circuit is considered to be dead and safe to work on. Physically secured by a lock, by putting a lock and a tag on it. and it should be clearly labeled, and the circuit should be tested. Double insulation is another very good control measure. Live parts or parts that might become light by fault, they also need to be protected, and an insulation is provided so that they cannot be touched easily. Often it is achieved by having two layers of insulation between live conductors and any external metal surfaces, or external metal surfaces are non-conducting or plastic. So basically the conductor is wrapped around in double insulation, two layers of insulation. Okay, residual current device is also very, very important. They are specifically designed to protect human life. RCDs, they protect human life. Constantly compares the current in live and neutral wires, and it is sensitive to small current imbalances. For example, if there's any leakage to earth, it is very, very sensitive, and it will pull, what you call it, it will blow the fuse. It can be used as part of a plug as a standalone device. It can be hardwired into the electrical distribution system as well. Then another very good control measure is the use of reduced and low voltage system. As voltage is reduced, so the shock current is also reduced as well. In UK, there's 230 voltage, which is stepped down to 110 volt for portable power tools as well. Usually 50-volt equipment is considered safe equipment, and it is extremely low voltage. Okay, and 50-volt equipment, it will never give you an electrical shock. Okay, reduced and low electrical voltage system. Basically, these are control measures when selecting the portable electrical equipment on construction sites. So you need to use battery powered equipment, and or reduced or low voltage equipment should be used. RCDs should be available on all equipment. Locate the cables carefully. Don't run them along sharp edges. Use double insulated equipment. Carry out pre-use checks. Train the operators in the correct use. Avoid using it in wet conditions, and implement routine visual inspections as well. Competent person, obviously they should be only allowed to work on electricity. No one should be allowed to work on electrical system unless they are deemed competent persons. So competent person should have knowledge of electricity, experience of electrical work. They should have understanding of the system and the hazard and precaution. They should also be able to recognize whether it is safe to work or not. Safe system work should be implemented in electrical systems. You should always work when, if it is possible, to make sure that the system is dead. Try to avoid working on a live system, and working on or near live electrical equipment, you need to take a permit, and you should only be allowed to work under exceptional circumstances on a live system. Okay, working near live electrical system, it's a very, very hazardous activity, and you should never work on live system unless there is no other alternative. So if you do work on live electrical system, these are mandatory things you need to follow. You need to have a permit to work system, always competent people to do the job. Insulating PPEs must be provided, such as boots and gauntlets. Insulated tools and equipment must be used, and designated work area only. Isolation usually requires the breaking of the circuit. So you need to switch it off or pull the plug, and then physically secure the break in the circuit by putting a lock and a tag around it. Okay, another very common electrical hazard is the contact with buried electrical cables. Most of the time, the electrical cables, they pass under the ground. So underground cables, electrical cables, they can also cause serious electrical shock if during excavation, the excavator or any other equipment, if it comes in contact with the buried cable, it can cause a serious electrical shock. It can cause arcing, shock, burns, and fires. So how do you prevent something like this from happening? You need to check all the plans, check the drawings, identify the underground cables, use detection equipment such as a CAT scanner or a metal detector, expose them by hand digging, and identify them and label them as well. Working near overhead power lines is also very, very dangerous activity. So you need to make sure that you take all the precautions, because overhead lines almost always they are uninsulated. So you will never see any insulation over overhead power lines. Okay. So what control measures you should take while working near overhead power lines? You need to arrange isolation or a cover sleeve, which you can install temporarily on these overhead lines. Use a safe system of work and a permit to work system. Use barriers, signs, and goalposts. Use a banksman or a signaler, and use non-conducting equipment. Okay, what emergency procedures to follow in electrical incident? Very, very important. Never ever touch the casualty. If you suspect that somebody has received an electrical shock or has undergone an electrical incident, you should never touch the casualty. Call for the ambulance. Then you should turn off the power supply. Identify where the power supply is and turn it off. If you can't switch off the power isolate the casualty from the supply by using a wooden stick or any other insulating material. Then, once you separated the injured person from the power supply, you should check for breathing, put in the recovery position if the person is breathing, and if the person is not breathing, you need to start CPR. CPR is a type of first aid. It is known as cardiopulmonary resuscitation. Cardio is your heart, pulmonary is related to your lungs, resuscitation means revival. So basically, there are two systems which keep you alive: your respiratory system, which is your breathing, which is depending on your lungs, or your pulmonary system, it is also called. And then there is the cardiology as well, your circulation as well. So circulatory system takes oxygen from your lungs to all parts of your body. If any of these systems stop working, then a person can die. Okay, so you need to start CPR, cardiopulmonary resuscitation, if the person is not breathing, and should only do it if you're trained to do it. Don't experiment on people. Treat the burns, treat for psychological shock, physiological shock, and ensure medical help is obtained. Inspection and maintenance of electrical systems is also very, very important. You should do inspection maintenance to fixed wire systems and portable appliances as well, and carry out combined inspection testing. One common type of testing is called the user checks. The person who is using the electrical tool or equipment, he should do user checks before starting by checking the body of the plug, outer flex sheet, plug and appliances. You should check the clamp is tight or not. The flex should be fully insulated. There should be no splits or kinks. Body of the appliance should be intact. No damage to the casing of the equipment. No burns or scorch marks should be there, and it should not be soiled or wet. Okay, user checks. You should also make sure you need to check the fuse, the connections are secure, terminals are secure, and no signs of internal damage, and it should be done by a competent person. Then there's a combined inspection and testing. Visual inspection test may not identify some defects, so you need to do a what you call it a combined testing, which can detect deterioration of insulation and defective earth or pathway. You should carry out inspection tests when you suspect the equipment is defective, or if there is any repair or modification after certain intervals, and should be done by a competent person as well. Frequency of inspection and testing should be determined by the legal standards, the type of equipment, manufacturer's recommendation, the integrity and soundness of the equipment, how old the equipment is, so age of the equipment, what kind of working environment you are using the equipment in, frequency and duration of use, and also any foreseeable abuse of the equipment, and any effects of modifications or repairs, and analysis of previous maintenance records. So you should consider all of these factors while deciding on the frequency of inspection and testing. Okay, the advantages and disadvantages of portable appliances testing. The advantages are you can detect the defects and faults which are not visible to the eye. You can carry out early removal or repair of the equipment, demonstrates compliance and identifies trends and patterns. Limitations are it provides proof of safety at one time, one moment only. So you cannot guarantee that the equipment will always be safe. It does not ensure safe use or prevent misuse. Items may be missed, and it can be applied to all equipment as well. Okay, guys, so that is the end of element number 11. So we have completed our IG2 modules as well.